Hey, welcome to another Nargilus 2 production. Today we're going to continue our discussion of Taylor polynomial approximations. Okay, so in the last video, we talked about how a tangent line approximation is an example of a Taylor polynomial approximation, right? But that we want to work with higher power polynomials to get a better approximation for our answers. Okay, so we're going to try to come up with a Taylor polynomial for any degree that we want to go to, depending on whichever degree you're asked for. So again, the goal behind this video is to find an nth degree polynomial to approximate the function f of x. So that polynomial will have the form of the nth degree Taylor polynomial centered at C. So this is what the form looks like. We saw this form a little bit at the very end of the last video when we tried to make that second degree Taylor polynomial approximation. But to do this, we need to find all of these coefficients, a1, a0, a2, all the way up to an. So we got to be able to come up with some kind of pattern that goes all the way as far as we want to go without having to do all the math each time. So let's talk about how we're going to do that. All right, we need to find a0, a1, a2, and we need to do all of that relative to these function values. So we're going to know a function. We need to know what f of c, f prime of c, f double prime of c, all right? We need to somehow get those into our equation. So to do that, we know that f of c is equal to the polynomial evaluated at c, right? So the function evaluated at that point x equals c is the same thing as the polynomial evaluated at c. So if I were to plug or substitute that into my equation that I have here, well, p of c would equal a0 plus a1 c minus c plus a2 c minus c squared. And we can go on forever if we want. A sub n c minus c to the n power. But all these are going to drop out, right? They're all zeros. Everything in between here is going to drop out as well. So p of c is equal to a sub 0. But p of c is equal to f of c. So that means f of c is equal to a sub 0. Okay? So f of c is equal to a sub 0. All right, that's good. That's what we want to do. All right, so now let's find the derivative. P prime of c. So let's find the derivative of p. P prime of x is, derivative of a0 is 0, it drops out. The derivative of a1 x minus c will be a1. The derivative of a2 x minus c squared is 2a2 x minus c. And we can go on forever. The derivative of an x minus c to the n is n an x minus c to the n minus 1. So now, if I were to substitute in c to the derivative of p, I'd get a1 plus 2a2 c minus c. That drops out. All these other terms are going to drop out. They're all going to have c's in them still. And then the last term, c minus c, that drops out. That's gone. And the only thing left is a1. So that means f prime of c is equal to a1. So now we know f prime of c is equal to a1. And again, we're trying to get help here because if we know what the function is that we want to build the polynomial at, if we can take these coefficients and write them in terms of the function somehow, then we can substitute them in there and make a polynomial out of it. All right? All right, so let's do the same thing now with the next derivative. So p double prime of x, a1 would drop out. The derivative of 2a2 x minus c would be 2a sub 2 plus, well, we could go on forever. And then we'd have n minus 1 x minus c to the n minus 2. So if I were to find p double prime of c, that would be 2a2 plus all of these terms afterward will still have an x minus c in it, right? If we were to look at it, let's say we had a3 x minus c cubed. Let's add a term there so that you can see it. The first derivative would be 3a3 x minus c squared. The second derivative would be 3 times 2 a3 x minus c. So then when I found p double prime of c, this term would drop out as well. All right, all the other terms will drop out here. And then the last term also drops out, because when I substitute c minus c is 0 again, this term drops out. And I'll be left with just 2a2. So f double prime of c is equal to 2a2. So if I divide by 2 on both sides, a sub 2 is equal to f double prime of c over 2. So f double prime of c over 2 is equal to a2. All right, that's 3 of the coefficients. But I want to be able to do this for the nth coefficient, no matter how far we go. All right, so let's go to the next slide here, and we'll write out a couple more terms so you kind of get the idea of what's happening. So let's say I had p sub n is equal to a0 plus a1 x minus c plus a2 x minus c squared plus a3 x minus c cubed plus a4 x minus c to the fourth plus, keep going, an x minus c to the n power. So now let's start finding derivatives. So p sub, or p1, first derivative, would be, with respect to x, the a0 drops out. I'd get a1 plus 2 a2 x minus c plus 3a3 x minus c squared plus 4a4 x minus c cubed plus n x minus c to the n. All right, and then if I were to substitute c, the only thing that would be left would be the a1. So let's find p double prime. So a1 drops out. I get 2a2 plus 3 times 2a3. And there's a reason I'm writing this and not writing 6. You'll see in a minute. Plus 4 times 3a4 x minus c squared plus n minus 1. Oops, this should be n minus 1 up here. A sub n x minus c to the n minus 2. All right, and then if I were to plug c in, we did this on the last slide, we end up, all these terms drop out. They all have c's in them. They all become c minus c. And I get f double prime of c is equal to 2a2. So now let's find the third derivative. The 2a2 will drop out. That's a number. I'll get 3 times 2 times a sub 3 plus 4 times 3 times 2, a sub 4, x minus c, plus n minus 1, n minus 2, a sub n, x minus c to the n minus 3. So now if I were to find f triple prime of c, or p triple prime of c, all of these terms would all drop out, everything to the right of 3 times 2, a3. And that's going to equal f triple prime of c. So if I divide both sides by 3 times 2, I get a sub 3 is equal to f double prime of c over 3 times 2. If I were to find the fourth derivative evaluated at x, this term drops out. I get 4 times 3 times 2a4 plus n minus 1, n minus 2, n minus 3, a sub n, x minus c to the n minus 4. And then the fourth derivative evaluated at c would be 4 times 3 times 2 times a4. And then all these terms would drop out afterwards because they'll all still have an x minus c in it, and I'm substituting c in. that would be equal to the fourth derivative evaluated at c, which means a4 would be the fourth derivative evaluated at c over 4 times 3 times 2. So hopefully you're starting to see what's happening here. It's because of the power rule that I keep dropping one power down each time and multiplying by another one of those coefficients in front, making the power the coefficient and multiplying, but it's decreasing by one every time. So a5 would be the fifth derivative evaluated at c over 5 times 4 times 3 times 2. Now I can write 5 times 4 times 3 times 2 in a simpler way, right? So I could write this as 5 factorial. And I could write this as 3 factorial. Or this is 4 factorial. And then eventually I'd reach the nth term, and a sub n would be the nth derivative evaluated at c over n factorial, however many numbers you want to go, okay? Whatever degree you want to write. And that is how you write the equation for a Taylor polynomial, with those coefficients substituted in. So, the name of the game, the nth term Taylor polynomial centered at c, is equal to f of c, that's your a0, that's your a1, that's your a2, and that's your an. Okay? If c is equal to 0, we give the polynomial a special name called a Maclaurin polynomial. So if ever I ask you to write the Maclaurin polynomial, you know automatically the center is at 0. All right? So then c would just be 0 every single time, and it would just leave me with an x rather than an x minus c there. But this is really the same formula. Okay? And this is the formula you're going to need to write a Taylor or a Maclaurin polynomial for any degree that you want. So if I were to say write something to degree 4, well, degree 4 would be t sub 4 of x would be f of c plus f prime of c, x minus c, plus f double prime of c over 2 factorial, x minus c squared, plus f triple prime of c over 3 factorial, x minus c cubed, plus the fourth derivative evaluated at c over 4 factorial, x minus c to the fourth. All right? So that's really what you'd be working with there. Okay? And that's it. All right? In the next video, the final video, we're going to use these formulas to actually find Taylor polynomials. As always, thanks for clicking.